Next time you're outside, whether you're in the city, out in the countryside, in the vast boreal forest, or in the rolling foothills in the shadow of the wondrous Rocky Mountains, wherever you are, look down and ask yourself, what do you see? No matter where you are in Alberta, I can tell you that you're standing on top of vast amounts of energy. Energy that can power our homes, our vehicles, and keep us warm in the winter. Over the next 2 episodes of Carbon Copy, we'll be exploring the present and future of the energy beneath our feet, and how 2 innovations are making it easier, more affordable, and cleaner to harness these incredible sources of energy. Today, we sit down with Julian Ortiz from ConocoPhillips Canada to talk about SAGD, thief zones, and how innovation is driving Alberta's oil sands industry forward. Here on Carbon Copy.
If you compare bitumen to molasses, even molasses, flows better and more easily than bitumen. So, we need heat to make it flow. So with SAGD, we drill horizontal wells. So this is an in situ process. So we're not talking about mining here. So we drill 2 horizontal wells. The upper well injects steam, and the bottom well is the oil producer. So basically, over time, that steam transfer heat to the bitumen, and the bitumen, flows more easily.
Thanks, Julian. That's very helpful context for the innovation that we want to talk about today. So then the first thing I want to know is, what is a thief zone, and how did it get such a cool name?
Yeah, that's right. So it has a cool name, but it's not cool to us, I guess. So, basically, in these oil reservoirs, some cases we have water or gas above those oil reservoirs. So, as I was saying before, in SAGD, we have to inject steam to produce bitumen. So when you have thief zones, that water or gas, they steal the heat and the pressure from steam. So it basically doesn't allow us to produce bitumen efficiently, because we're only heating up that overlying water or gas and not the bitumen that we need to produce.
Okay, so you're operating a SAGD facility and you're injecting steam into the reservoir to mobilize the bitumen, but you run into some water that is essentially stealing the heat away from the reservoir. So what do you do about that?
Yeah, so, over the years, we've been looking at different options that can mitigate the negative impact of thief zones. And one of those solutions is the co-injection of non-condensable gas, or NCG for short. Basically, NCG is, imagine methane, or the same gas we use to generate steam at these plants, right? So to generate steam, we have to burn natural gas, which is basically methane, to generate steam. So instead of running that gas through the plant and burning that gas and generating steam, we are co-injecting that gas directly in the reservoir. So the benefit of co-injecting NCG is that given that it has a non-condensable nature, meaning that it will not turn into liquid, then that NCG will go to, will move to the thief zone and start displacing that thief zone away from our producing area. So, when you start displacing that, a thief zone or the liquids in the thief zone, then the process becomes more efficient. And at the same time, you're not burning a lot of gas to generate steam. And then that's how we see some of the benefits in the greenhouse gas emissions front.
Very cool. So why is it important that it's a non-condensable gas and that it it doesn't turn into a liquid or it remains in the gas phase?
Yeah, so, if we don't have that non-condensable nature, then, it will become liquid when the temperatures go down. And then if it becomes into a liquid, then, it will not have the same capacity to go to the top of the reservoir or above the old reservoir in this case, right? So, and it doesn't have the same ability to insulate, if you will. So think about, you have, your SAGD process, and you want that heat to be inside a chamber. So, bitumen can be melted and produced. So, that gas helps you insulate that chamber from the thief zone, and also helps to displace some of the liquids in the thief zone. If the gas becomes liquid, at low temperatures, then it will not have that ability to insulate your chamber, and also to help you with the thief zone.
How common are thief zones by way of SAGD reservoirs?
Yeah, so I would say that they are common in certain areas. So, for instance, in the area we operate, they are prevalent. So, initially in the early 2000s, when SAGD was becoming the method of choice to produce bitumen in situ, the old companies were targeting areas with no thief zones, because if you have a thief zone, then it means your process is not as efficient. You need to inject a lot of steam, and the process might not be economic. So, many operators were targeting areas with no thief zones. As we now progress into, more complex parts of the reservoirs, then we'll start encountering thief zones. And, one of the particular things that we have observed in our reservoirs is that, when we look at the reservoir quality, in terms of how easy we can produce that bitumen, we have those really good areas right below thief zones, which is so unfortunate. If we didn't have those thief zones, then the process will be extremely efficient. So you never get the perfect scenario in this case. So now the producers will start facing more of these situations where, hey, if you want to keep developing those assets, you will start encountering those thief zones. And, we need to have a solution in place if we don't want to, perhaps have non-economic, developments, or, really high greenhouse gas emissions. Because, in those thief zones, if you don't have any solution in place, your only solution is to inject more and more steam. So, this is like a monster, that you have to feed every single day with more and more steam. And you want that steam to do work for you, not to work for this thief zone or the monster in this case, right? So that's why, it's important to have a solution in place now, because in the future we will have those thief zones as challenges.
So if this solution works, then could it have a fairly large impact across a number of oil sand reservoirs?
Yeah, absolutely. And just to step back a little bit, this technology of non-condensable gas co-injection, or NCG, works as well for in cases where you don't have thief zones. So that's the beauty of this technology, right? So it's so versatile in terms of, hey, if you have a reservoir with no thief zone, then that's great. It can help you with the insulation effect. And then if you have a thief zone, then it can really mitigate the impact of thief zones. So it's a really good solution, low cost. Of course, not all the the reservoirs will be suitable for NCG co-injection, but in most situations, you can apply NCG co-injection. So I would say that eventually and we've seen that already. Many companies are already using NCG, but eventually I think NCG will be be part of the day-to-day operations for the oil sands in terms of SAGD operations.
So what happens then at the end of the reservoir life or at the end of the well pad life when you're drawing down the reservoir? What happens to all the non-condensable gas that you injected into the reservoir? Can you get it back out? If it's natural gas or methane, can you make use of it?
Yeah, for sure. Yeah. So, that'll be an interesting thing to see in the future when we have depleted those reservoirs, what to do with that gas. If there's, economic value for that gas, yeah, absolutely, we'll have the ability to produce that gas to surface again.
Well, I understand that ERA is providing funding for a demonstration of the technology to validate performance at a commercial scale. Tell me a little bit about that project and what you were hoping to accomplish in the project.
Yeah, we're really thankful for the support we got from ERA a few years ago. And just to bring a bit of context, back in 2014, between 2014 and 2016, we started doing a lot of technical feasibility work to see if this technology would be applicable to our SAGD asset. All the work indicated that yes, that could be a really good solution for a better use of steam. And the first application was in an area of known thief zone in that case. So we proved the concept. It went really well, and then we saw the challenge with areas where thief zones were present. Those were challenging times. 2016, 2017, the industry was going through this really difficult downturn, and we still are. But at that time, it was so hard to get funding for this technology implementation. So we approached ERA to ask for help to trial this technology in an area where thief zones were pervasive. And then fortunately we got the funding from ERA, which allowed us to trial the technology under these new circumstances, and we demonstrated that the results were really good. And then from there, it allowed us to continue deployment across many areas. As of now, 1/3 of our entire SAGD asset is on NCG co-injection, and we're planning for more in the next few months. So really thankful to ERA for their support, because it allowed us to de-risk the technology, which is a really important thing nowadays, right? So given the economic conditions, it's hard to demonstrate or to ask for funding when you have not de-risked your technology. So ERA really helped us to do that.
Yeah. Well, thanks very much. I'm really glad to hear that. So maybe just to put a finer point on it, can you tell me what happened in the project? What happened when you injected the NCG into the reservoir? Do you have evidence that it pushed aside the thief zones or insulated from the thief zones? Talk a little bit about the results of the project, if that's all right.
Yeah, for sure. So, the context for the pilot was, we have a pad of 12 well pairs. So a pad is basically, a terminology we use to indicate that, on surface, we drill wells from pretty much the same location. So this pad has 12 well pairs, and before NCG co-injection, we were seeing a lot of interaction with the thief zone, meaning that we were injecting steam, and some of that steam was being stolen by the thief zone, and we were not using steam efficiently in the reservoir. So our oil rates were struggling a little bit. And one of the main indicators in SAGD is the steam oil ratio, or SOR. Just for context, if your SOR is around 2.5, that's considered normal. If it's below 2.5, then that's really good. If it's above 2.5, then you have to do something about it. In our case, those numbers were trending upwards, higher than 2.5. So that's a concern, because that means that your steam is not doing work for you. It's doing work for somebody else, in this case, the thief zone. So, we saw NCG as a solution for that, and we started co-injecting NCG. So basically, the results were, we were able to see that NCG migrating to the thief zone, and by doing that, then we were able to cut the steam injection. So, imagine if you're injecting, just for context, if you're injecting, just to give a number, 100 cubic meters of steam per day, and then let's say 50 cubic meters of steam are being stolen by the thief zone and only 50 are being used for oil production, you want to get rid of the 50 that, are not doing anything for you. And that's exactly what we did with NCG co-injection. That NCG co-injection allowed us to cut that, call it sacrificial steam, because that steam is not doing anything. It's just, being stolen by the thief zone. And then, during the operation of the pilot, which lasted about 18 months, we saw reductions in SOR, the steam-oil ratio, reductions of 20% plus. So, which is huge in the SAC-D world, right? So, what can you do with that steam that you free up from those areas? You can reallocate it to new areas, or you can do something else at the steam plant. And at the end of the day, if you have an SOR reduction, then your greenhouse gas emissions intensity go down, because you don't have to burn a lot of natural gas to maintain oil rates. You just, you bring your SOR down, the process is efficient, and then, the project is more economic and more environmentally friendly.
Across Alberta, there are innovators, entrepreneurs, and technology developers with big ideas to grow our economy and reduce greenhouse gas emissions. But the current economic reality means that many of these projects are not moving forward. Emissions Reduction Alberta is going to jumpstart shovel-ready projects with $150 million in new funding to support job creation and help drive our economic recovery. From process optimization to transformative technologies, from capturing waste heat to utilizing industrial carbon, these projects will create jobs and reduce emissions. Work on these projects will start within just 60 days of ERA's funding approval, kickstarting Alberta's economy right here, right now. To learn more about the Shovel Ready Challenge, visit eralberta.ca. So I'm wondering, to the extent that you can you help translate this into dollars and cents for me? How much money does this save, or operating cost does this save, and how much does it reduce greenhouse gas emissions?
Yeah, so, I'll address the greenhouse gas emission numbers first. So, SOR reductions almost, directly translate into greenhouse gas emissions, right? So, if we saw a SOR reduction of about 20%, then your greenhouse gas emission intensity reduction is about 20% as well. So, which is really good. Now, if you start scaling that, that application to, from one pad to 2, 3, 4, to, the extent of the entire field, then that's massive, right? So in terms of economics, so we've seen savings in, the cost of production per each barrel of oil. So I'll not give any specific numbers about that, but, savings from that point of view. And then if you can use that steam more efficiently, then the overall economics of your project improve, because you're not wasting steam. Steam is expensive, and you don't want to waste it, right?
After hearing this, is it fair to say that this project was a resounding success?
Yeah. For us, it was a resounding success, and then, from that pilot, we decided to expand it to different areas, right? So that's basically testimony that this technology works, and we are, we're willing to continue its deployment across the entire field.
So I want to maybe put a little bit of a finer point on the next steps right away. But before I get to that, I had a question around the role of collaboration. And you and I will recall, if we go back to the meeting room where you presented this idea to the ERA team, there was some discussion around collaboration. So what has been the role of collaboration working with industrial partners, with COSIA and with other COSIA members to help shape the technology to where it is now?
Yeah, so for the audience, if for those that don't know what COSIA is the Canada's Oil Sands Innovation Alliance, and basically consists of different priority areas. We have water, land, greenhouse gas, and the newest priority area is Innovation Plus. So, under Innovation Plus, different COSIA members discuss, technologies such as non-condensable gas co-injection, steam additives, wells technologies. And that's how, we brought this NCG technology to the COSIA table. We saw how, different companies were showing a lot of interest, about developing NCG and commercializing NCG. So recently, back in January this year, we signed a joint industry project with all the COSIA members. So we have Cenovus, Sancor, and Imperial, signing this JIP or joint industry project with ConocoPhillips, and basically opening their books on about NCG. And for us, we shared success of our NCG pilot. So how we went from high steam oil ratios down to really good steam oil ratios, what challenges we faced, how we were monitoring the performance of the wells. So I think that has gone really well, and for ConocoPhillips, industry collaboration in the oil sands is critical to for all of us to lower the overall carbon footprint in the oil sands industry, and also to be faster and more nimble when it comes to technology implementation. We can't afford to develop technologies that take 1 or 2 or 3 decades, because we may not have the time nowadays to spend that much time. So we're putting our talent together to develop technologies that can help reduce greenhouse gas emissions and make us more competitive from that point of view.
Yeah, thanks, Julian. I think that's a really important message for our audience, so thanks for sharing that. Okay, so you've now completed a successful demonstration that reduces greenhouse gas emissions and reduces the cost of oil sands recovery where the reservoirs are affected by thief zones. What's next for this technology? Can you apply this to existing SAGD operations, or can you only do this at a new facility?
And no, it can be used in existing operations. So, the flexibility and the versatility of NCG is wonderful, right? So, we can apply NCG when you have thief zones, different reservoir qualities. Of course, there's a time for NCG to be applied. So, I think the industry knows that, NCG will not be able to be applied day one from the operation, because, the nature of SAGD is that, you need that heat chamber or steam chamber to grow. So, if you apply NCG way too early, then that chamber will not grow efficiently. But then once that chamber is large enough, then NCG will be able to reduce the steam oil ratio and make the process more efficient. But absolutely, it can be applied in brownfield. So brownfield is existing areas of production, and also greenfield or new areas when the chambers have reached a certain size. But it's so versatile that you have the flexibility to apply NCG at any point. And also the other nice thing is, if things do not go well, the process is reversible. So for instance, if for some reason NCG is not doing any work for you, or you're seeing some detrimental impact to your oil rates. You can basically turn that off and then flush that NCG out of the reservoir, and then things will go back to normal. Nothing is changing the nature of the reservoir in a sense that now you cannot produce oil anymore. That's not the case. So it's reversible and so flexible as well.
Do you need any additional wells to inject the NCG, or can you do it through the existing well pairs that are there for the SAGD operation?
Yeah, so no, you don't need additional wells. So in our case, we co-inject NCG with steam. So in SAGD, as I said, the upper well is the injector. So we inject both steam and NCG through that injector. And then, once it enters the reservoir, then the NCG will start, because of gravity segregation, it will start moving ahead of steam and going up in the reservoir. But you don't need extra wells. There may be some cases where some reservoirs will require, let's say, more NCG volumes, and perhaps an operator decides to drill additional wells. But the flexibility of this technology, is so high that you can use your existing facilities. Minor changes to surface, relatively inexpensive. So it's really, really good.
Can you talk a little bit more about how you plan to share the results of this work so that the whole oil sands industry and the province of Alberta can benefit?
Yeah, so I think that the first step was our collaboration through COSIA, and those are technical collaborations, of course. There was a piece in CAP I think it was like probably a year or 2 years ago, where we were basically showing the benefits of NCG to the general public, and basically indicating that, hey, there are technologies that we are implementing that will make these assets more carbon efficient. So at the end of the day, what we really need to do is make these assets competitive in terms of cost and economics, but also to make them competitive in terms of greenhouse gas emissions. So yeah, we did that through CAP 1 or 2 years ago, and also we engage with many different technical groups like CHOA or the Canadian Heavy Oil Association. Also discussions with SPE conferences and workshops. SPE is the Society of Petroleum Engineers. So we're trying to disseminate the message, and then we hope that this technology can help the industry to reduce greenhouse gas emissions.
Can you tell me about any other exciting technology solutions that you and your team are working on?
Yeah, so probably what we have in the public domain. So for instance, flow control devices has been a technology that we've been implementing for a few years, and we continue to make it better. And what they do is essentially helps you utilize steam more efficiently. So at the end of the day, you'll see a common theme here is that you need steam to do a really good job for you. So you wanna reduce your steam oil ratio with whatever technology at your disposal. So NCG helps. Flow control devices help. Imagine if you have like a garden hose and a sprinkler, right? So if you want to water your lawn or garden, this sprinkler system will help you distribute the water efficiently, right? So you're not wasting water. So flow control devices do a really similar thing in the reservoir. So we put those devices in the wells, so you have that kind of sprinkling system downhole. So steam, is better utilized in the reservoir, not only going through, certain locations, but you have a more uniform distribution along the well. the other one that we've been working on, and we got funding from ERA as well, is the multilateral well technology. So essentially with that technology, we are making use of existing facilities and existing wells, but instead of having one well from surface or one downhole location, we're now drilling another one. So imagine that you have only one wellhead on surface, but now you have two horizontal wells downhole, and then we achieve that by using a multilateral junction technology downhole. Imagine like you have a fork downhole, and then the value of this innovation is huge because SAGD operates at really harsh conditions, so high temperature, high pressure. So it's not an easy process and not a gentle process to materials, right? So, the value of that technology is huge because now you can save money in new wells. You can, in SAGD, you can access the areas that, your existing wells are not accessing, right? So that's another, great piece of technology. And, we keep working on other technologies that haven't seen the public domain yet, but we are kind of relentless when it comes to finding technologies that will make us more competitive when it comes to greenhouse gas emissions and also when it comes to cost, right? So we want this asset to be resilient when it comes to cost and carbon footprint.
Well, I'm really excited to see what the future holds for these innovations. So thank you very much. Is there anything else I didn't ask about that you want to share with our audience?
I think that one thing for the general public is we hear a lot about probably the oil sands operators are not doing enough to cut their greenhouse gas emissions. But I want to say that nobody gets up in the morning saying, this is a great day to pollute the environment or something like that, right? So personally, I have two kids. I want them to, of course, breathe clean air, live in a prosperous city, province, country. So, and I think that, everybody in this industry is working really hard to achieve that. So, the industry is doing a lot to develop technologies that cut greenhouse gas emissions. Do we need to do better? Yes, and I think we're doing better every single day. And now, as I said before, nobody can afford to spend 10, 20, 30 years to develop technologies that help us cut greenhouse gas emissions. We're doing it, much faster than before. So, I just want the people to know that nobody's just happy to see that the greenhouse gas emissions are high. Everybody's working really hard to bring those emissions down, and the results are showing that the industry is doing a good job, and we'll keep doing a good job at reducing our greenhouse gas emissions and our carbon footprint.
Well, thank you very much, Julian, for talking to me today and also for your efforts to push forward groundbreaking innovation. Thank you once again.
Thanks, Mark. It's great talking to you.